Hello everyone and welcome to yet another math video. In this video, I'll be going over radical equations. So normal layout here, I'll go over the terms and definitions, I'll go over the process on how to solve radical equations, and then I'll be going over some examples of radical equations, including one square root, equations that have two square roots in them, and then a couple of equations at the end involving higher roots, like cube roots, fourth roots, fifth roots, etc. Let's get into it. Just a few terms to make sure everybody is on the same page. When we refer to radicals, we are simply referring to this radical sign here. You're probably familiar with it. I have a b root here. And some of the common radical signs that we use are a square root and cube root, otherwise known as second root and third root. And you can tell this is a third root because the 3 is in the little valley here. And we do not write the 2 in the valley for a square root. It's just taken, it's implied, we know that we're taking the second root. But after the cube root, we just name the roots by the number. So this would be the fourth root. If I changed it to a 7, that would be the seventh root. We generally don't use any specific names like square or cube for roots past 3. As far as the other term goes for this lesson, we have extraneous solution. This is a solution that does not satisfy the original equation. Even though you went through and did all of your work correctly, the answer may not work in the original equation. So we have to be checking our answers, which you'll see on the next slide. The process for solving a square root equation is as follows. The first thing you want to do is isolate a radical. From there, you need to raise both sides to a power to eliminate the radical, aka reduce the radical away out of the equation. From there, you may have to repeat steps 1 and 2 until all radicals have been eliminated. In some examples, there will be 2 radicals, and we have to go through this process twice. We have to isolate a radical and eliminate it, then we have to isolate the other radical and eliminate it. So just so you know, keep repeating steps 1 and 2 until all radicals have been eliminated. After all radicals have been eliminated, you'll be left with some kind of recognizable equation that you've already solved, linear or quadratic or the like, and you'll just solve for the target variable in the resulting equation. And the very last thing you have to do is check your answers. As I mentioned on the last slide, we could end up with extraneous solutions, which are solutions that, while you got the answer, you got the solution, will not satisfy the original equation. All right, let's jump into some examples. In this first example, we have the equation, the square root of 3 minus 2x minus 3 equals 6. Now the first thing we need to do is isolate the radical, which is right here. In this case, it's a square root. That'll come into play here in a moment. But we can add 3 to both sides to isolate the radical. This will zero out, giving us a 3 minus 2x left over on the left side, and 3 plus 6 is 9 on the right. Now that we've isolated the radical, or in this case the square root, we need to raise both sides to a power. Now, it's very easy to know which power to raise to. This is a square root, which means technically there's a 2 here, and to get rid of that, you probably understand the opposite of square rooting something is squaring something. So we will square both sides here to get the new resulting equation that will reduce with the square root. 3 minus 2x equals 9 squared on the right side is 81. You can see that the resulting equation is linear, which means you can use normal linear solving techniques to solve for the target variable, in this case, x. So I'm going to subtract 3 from both sides to go ahead and get negative 2x equals 78. And then I can divide both sides by negative 2 to get x equals negative 39. Now, this final answer here is a proposed answer. It's not our answer yet. We have to check. So off to the side, I'm going to do a little check here. And all I'm going to do is I'm going to substitute that answer, negative 39, in for x into the original equation. So I have 3 minus 2 times negative 39. All of that would be in the square root. Minus 3 equals 6. So it looks like we just have to simplify things on the left side of the equation. So to make this as quick as possible, negative 2 times a negative 39 is 78. So in the radical now, we have 3 plus 78, because a negative times a negative is positive. Minus 3 equals 6. All right, 3 plus 78 is 81. So I have a square root of 81 minus 3 equals 6. And then the square root of 81 is, in fact, 9. Minus 3 equals 6. And I can say for here, 9 minus 3 is, in fact, 6. This is our answer. X equals negative 39. In this next example, we have the equation 3 times the square root of 5x minus 4 plus 17 equals 11. So from here, what we can do is we can isolate the radical. So again, the radical is here. We need to isolate the radical. So the first thing I'm going to do is subtract 17 from both sides, like so. Remember, we have to do all of the adding and subtracting first, so that will zero out. That means I'll be left with 3 times the square root of 5x minus 4 equals negative 6. Now we haven't isolated the radical yet. We still have this factor of 3 being multiplied to the radical. So the next step here would be to divide by 3. Once we divide by 3, then we can see the radical will be isolated. 5x minus 4 equals negative 2. Now that the radical has been isolated, let's go ahead and get rid of it. I know this is a square root, so I know there's a 2 down here in the valley. So I have to raise both sides to the second power in order to eliminate the square root, the radical. Once you do that, the left side, pretty simple, 5x minus 4. The right side, negative 2 squared. Notice I encompassed the entire side in parentheses. So this will be negative 2 times negative 2 is going to be positive 4. Now from here, again, the solving techniques become pretty familiar because this is a linear equation. I can add 4 to both sides. That will zero out. I will get 5x equals 8. I can divide both sides by 5. That will reduce away, and that leaves me with x equals 8 over 5. Again, this is a proposed solution, so I'm going to come off to the right, and I'm going to do a little check here. So let's write check. I'm going to section this off. And what I'm going to do is I'm going to put 8 over 5. I'm going to substitute it in for x in the original equation here. 8 over 5, there's that, minus 4, square root, plus 17 equals 11. All right. Again, it looks like we only have to simplify what's on the left side of the equation. Sometimes in the future, you may have to simplify both sides of the equation. Just saying. So it looks like as we go through and simplify the left side, we have to start inside the square root. The 5s here will reduce down to 1, leaving us with an 8 minus 4 in the radical, plus 17, there we go. Let's see here, 8 minus 4 in the radical is 4, so I have a 4 in the radical. The square root of 4 is 2, 2 times 3 is 6. So I'm just kind of doing those at the same time. So 6 plus 17, and this 11 follows along for the ride. And I can tell that 6 plus 17 is definitely not equal to 11. So what happens? We did all the correct math work. The answer didn't work. This answer is no good. We would say extraneous, which means our answer is no solution. Next example, we have x minus the square root of 3x plus 4. All right, same idea. We have to isolate a radical. The radical that we're trying to isolate is right here. But you'll notice it has a negative coefficient. So what I can do to fix that is I can add the radical to both sides. 3x plus 4 plus the radical of 3x plus 4. I should say the square root of 3x plus 4. What that does is it eliminates it on the left side here, and we have x equals 3x plus 4, the square root of all that. We've isolated the square root. All right, so you know the next step is to raise both sides of the equation to some power to eliminate the radical. So again, in this case, 2. But you'll see now, this will be the first example of a resulting quadratic equation. No big deal. You know how to solve quadratic equations. You can use the factoring, square root property, quadratic formula, or completing the square, whichever one works best for you. So I will use factoring as I know this factors. So solving a quadratic equation means I have to move all terms to the other side of the equation. So we have an equals 0. So I'm going to subtract 3x and subtract 4 to zero those out. And I will simply write those in the correct form here on the other side of the equation. Now that we have quadratic equation set up for solving, I know that this will factor. So I'm going to come here and say factor and say this is x plus 1 times x minus 4 equals 0. And I think from here you can see that x will equal -1 and x will equal 4. Again, these are proposed answers. So what we have to do then is we have to go through and check. And yes, we have to check both answers here. And holy moly, we're only simplifying the left side again. All right, well, let's check it out. So I'm gonna make sure I notate that I am checking x equals -1. What that does for me is it tells me that I need to come over here to this original equation and substitute -1 in for both x's. So what that would look like is a -1 minus the square root of 3 times -1 plus 4 equals 0. All right, so as with the other checks, start within the square root. So here, 3 times -1 is -3. -3 plus 4 is a +1. So I've simplified it to this. -1 minus the square root of 1 equals 0. And I know the square root of 1 is 1. So this would be -1 minus 1 equals 0. It turns out that -1 minus 1 more is not 0. It is -2 equals 0. So this is false. So that means our answer down here, we cannot include x equals -1. We would say that is extraneous or extra. It doesn't count. We got an answer. It was an extra answer. It didn't work. So now we have to go through and check 4. All right, so let's check x equals 4. So same thing, I'm going to substitute 4 in for x. I'm going to substitute 4 in for x. And we're going to see if both sides of the equation are equal. All right, so 4 minus, I'm going to do some quick math here. 3 times 4 is 12. 12 plus 4 is 16. So this would be square root of 16 equals 0. So 4 minus, oh, the square root of 16 is just 4, right? 4 minus 4 is 0. This works. This is true. So x equals 4 would be our answer. And only x equals 4, because we proved earlier that x equals -1 does not work. For this next example, I simply want to go over something that will help you out in the next example. In this example, again, isolating the square root is here. So we would have to add 3 to both sides. That would leave us with 6x minus 1 square root equals 2x plus 3. Now that the square root is isolated, we know that we have to raise both sides to the second power. But I wanted to point out right here, the right side of this equation has 2 terms. And when I say raise both sides, each side to a power, you have to really wrap the entire side in parentheses and raise it to the second power. Now, the left side of this equation is not a problem. 6x minus 1 equals. What the right side of this equation is telling you is that 2x plus 3 squared means 2x plus 3 times 2x plus 3. So you will have to distribute this all out, right? You can do 2x times 2x, which is 4x squared. You can do 2x times 3 and 2x times 3, each of which is 6x, totaling up to 12x, and plus 3 times plus 3 is 9. So beware of this as you're going through examples, say like on the next slide, and everything should be fine. Now, if you want to go through and finish this yourself, I'm going to go ahead and tell you the answer here is no solution. And you'll see once you get into your checks that the answer will be no solution. All right, here's your one and only example with an equation that has 2 square roots in it. The first thing you want to do is isolate a square root. Now, that can be done any way you like. You saw earlier in an earlier example, I added a square root to both sides. To isolate, I would be isolating this square root. You saw too that I could subtract this square root from both sides to isolate this square root, to start isolating the square root. Now, however you do it is fine. It's not going to be a big deal either way. But I am personally going to move the square root of x from the left side to the right side. And that is because I will have a simpler squaring process, and you'll see here in a moment. So let's subtract square root of x from both sides. That will reduce that away, and I will have negative square root of x plus 16 equals negative square root of x minus 4. Now, I have not isolated a root yet. I have a negative root, so that means I'm going to come along and I'm just going to divide everything by -1, which I'm just going to do like this, say divide by -1 across the entire equation, and that will end up with x plus 16 equals square root of x minus 4. All right, from here, I can start squaring both sides of this equation. So I'm going to square this side, and that will reduce the square root away, but here it doesn't quite happen like that. You'll want to remember from the previous slide that this right side means we'll take the square root of x minus 4 and multiply it to the square root of x minus 4. I'm going to do it off to the side here, just a little bit of side work. So the square root of x times the square root of x simply reduces to, or simplifies to, x. The square root of x times negative 4 is negative 4 square root of x. Negative 4 times square root of x is another negative 4 square root of x. And negative 4 times negative 4 is a positive 16. So from here, we can combine these terms because they have exactly the same variables with exactly the same exponents, and we can talk about that some other time. But the x's are both in a square root. We have minus 4 and minus 4 of them, which combines to minus 8 square root of x here, plus 16 and x at the front. So all of this squaring turns into x squared minus 8 square root of x plus 16. And that will equal the right side of this equation. Again, pretty simple to figure out, is just going to be x plus 16. That being said, we still have a radical in this equation. So what we will have to do now is isolate this radical. And I will do that on the next slide. Here I have the last step from the last slide, and you can see that now, first time example here, we have to go back and repeat steps 1 and 2 of our process because there's a square root, aka radical, in our equation. It's still there. So if I want to isolate this, I first have to move the other terms that are on the same side of the equation. And so I will combine those terms appropriately on the right side of the equation. On the left side of the equation. Everything zeroes out on the left side of the equation, leaving me with 0. Now you can see that the radical is not completely isolated yet, so I'm going to divide both sides by negative 8. The negative 8 over here will reduce to 1. 0 divided by negative 8 is still, in fact, 0. Now I'm going to make a point of it. We can square both sides, and yes, this squaring was going to be a lot easier because it only had a single term inside of this radical. It might be a little more difficult if you had 2 terms on this side, or rather in this radical, but for right now, the square and the square root reduce away, and 0 squared on the left side is 0, so we get x equals 0. From there, we have to check, so I will check the solution, x equals 0. Back in the original equation, we had the square root of x, which is now going to be 0, minus the square root of x, which will be 0, plus 16, equals negative 4. So from this point, the square root of 0 is 0, check, minus the square root of 0 plus 16, that just adds up to 16, so the square root of 16 is 4, equals negative 4. So 0 minus 4 equals negative 4, yep, that's true. So x equals 0, sometimes 0 is really the answer. In this case, it is. X equals 0. From here, just a quick couple examples of working with larger roots than just a square root. So here you have a cube root. It's already isolated. Pretend you did some work to isolate it like you've seen already. So what we can do from here is recognize that there is a 3 in the root. So what that means is you will be raising both sides to the 3rd power. So whatever number your root contains will be the exponent you use to eliminate the root. So on the left side, you're left with 3x. On the right side, 8 times 8 times 8 is 512. And lastly, here, 3, we can divide by 3. And the 3 is reduced to 1 on the left, leaving you with x equals 512 over 3. So again, you can do a pretty quick check here. We have the cube root of 3 times 512 over 3 in the cube root equals 8. So on the left side, the 3's will reduce, and from there, you have the cube root of 512, which is in fact 8. So this answer is a good answer. Very similarly, over here on the right example, you can raise both sides to the 5th power. The 5th exponent will reduce with the 5th root. So you have 2x minus 1 equaling 2 to the 5th power is 2 times 2 times 2 times 2 times 2. 5 2's being multiplied together, 32. Add 1 to both sides. That will give you 2x equals 33. You can then divide both sides by 2, reducing the 2 on the left to a 1, and you'll get x equals 33 over 2. All right, that brings me to the end of this video on radical equations. I hope very much that this video has helped you out, and I'll see you in the next video.